This is part 2 of lecture 2. In this part of the lecture, we are going to become familiar with Weka terminology and with Weka's file formats. Let's say that this is a theoretical preparation for the lab class. First, we are going to see the difference between the notions of concepts, instances, and attributes. Then we will see what an ARFF file is and what it contains and so on. Let's focus on the input first, so on the training data first. A concept is the thing to be learned. For example, the different types of iris flowers. The instances are the individual, independent examples of a concept. So basically, in our case, it's the description of each iris flower. So the attributes measures the different aspects of an instance. So the attributes are sepal length, petal width, and so on. Attribute values are the actual measurements of these attributes. For example, 3.1 centimeters or 0.1 millimeters and so on. Often in language technology, attributes are called features. I think we have already talked about the different styles of learning. We have talked about classification, association, clustering, regression, and so on. So basically, in this context, the concept is the thing to be learned, and the concept description is the output of a learning scheme, so the output of a learning algorithm. With classification, the aim is to predict a discrete or categorical class. The classification is supervised when the input data contains the correct class. So the algorithm learns from the attributes associated with the correct class. In the test data, the class is there too, but it is not used for any learning. It is used to double check the performance of the classifier. So basically, the model ignores the labels during the prediction phase. The labels in the test data are used to check if the model's prediction match the actual class in the test data. With association, we want to detect associations between different aspects of a problem. Association learning can be applied if no class is specified and when any kind of structure is considered to be interesting. Association can predict not only classes, but also any other kind of attribute. Clustering refers to finding groups of items that are similar. Clustering is unsupervised, which means that the training data is provided without any label, any class label. So we have only attributes, we don't have any class. But we wanted to find sensible groupings anyway. Regression or numeric prediction is a variant of a classification. In this case, the class is a numeric value and not a discrete or categorical value. And regression is supervised learning. The input to a machine learning scheme or machine learning algorithm is a set of instances. In the standard scenario, each instance is an independent example of a concept, of the concept that we want to learn. An instance contains the attribute values. For example, an instance is an iris flower represented in terms of petal and sepal measurements. In other scenarios, an example might contain multiple instances, and this is called multi-instance classification. But we are not going to talk, or we are not going to handle this kind of cases in this course. An attribute is the trait, the feature that we think is good to represent a problem. So each instance, each example is described by a fixed predefined set of traits or cues or features or attributes. The choice of attributes can be subjective. It is normally based on the knowledge that we have on the field. For example, in the case of the iris dataset, possibly a botanist said that sepal and petal measurements were good traits to represent iris flowers. There are different types of attribute values. Attribute values can be nominal or numeric, or they can be interval based, or and so on. Nominal values are labels or names. Quantity might not be the right word for categorical attributes, but this is what Weka, this is the word that Weka uses. So we keep in mind that hot is not a quantity, but it can be quantified. Mild is not a quantity, but it can be quantified, and so on. Intervals refer to fixed unit. For example, year. We know that a year is 360 days, so it's an interval. And so on. So there are different types of measurements that we can use, but mostly what we will use are nominal values or and numeric values. In this slide, you have a short summary of different types of attributes. Just be very careful with the terminology, because each textbook uses slightly different terminology. And you see here that in the previous slides, the Weka book used the word ordinal to, let's say, for ordered measurements, while in this slide it says ordinal attributes are called numeric or continuous. So, well, we just keep alert that it might be confusing sometimes. So watch out the terminology, try to understand what it really means. So as I said before, we are going to use mostly numeric values and nominal values, categorical values. Preparing the input from scratch is not always trivial, because we might have different sources that we have to aggregate in one single data set, and these sources might have different styles or different measurements. So we have to normalize, or let's say to regularize the data. This is a snapshot of the ARFF file format, the native format used in Weka. In the latest version of Weka, basically several formats are accepted and then converted into the ARFF format. The ARFF format is a ASCII file, so you can create it yourself in any text ASCII text editor, and then write manually. For example, if you have a very small data set, you can write manually all the information. Normally, if you are computing some calculations or measurements, the ARFF format can be generated by your system. As we mentioned before, there are different types of attributes that we can use. In this slide, you can see the example of the string attribute. So basically, in this data set, we are supposed to have an attribute called description, and the format of this, the value of this description is a string. Or we might have another attribute which is called today, and the format of this attribute is a date. Sparse data is very common in language technology. So it happens very often, for example, in text categorization, that many attribute values are 0, as in the example that you can see on the screen. So Weka supports the sparse data formats, and if you compare the two pictures on the screen, you can see that in the first one, 026, 00063, and so on, all the non-present words, we assume that 0 are words that are absent from a text, are, let's say, written explicitly. Weka supports a format where you can only specify the, let's say, the existing words and the position they have in the data set. So if you look at the picture below the sparse data format, you can see that it says 126. So basically 1 is the position in the data set and 26 is the value of that attribute in the data set. So 1, why is it 1? Because the counting starts from 0. So 1 is the second position and 26 in the upper picture is in the second position. Sparse data means that there are many zeros. If you want to summarize this concept, there are many zeros in a data set, and this is a problem in many NLP applications, and you will find out why later. Another problem that we might come across when creating a data set from scratch is the problem of missing values. So either for some reasons we have not written a value, or our system has not included in the output a value. So this is an error system. Or maybe we are converting a data set from one format to another, and in the conversion some of the data went lost. It might also be that missing data means that simply we don't have data for an attribute. Well, there are several solutions that are offered to to address this problem. For the time being, if we have a missing value in our data set, it means there is an error. So it means for us that the data set we are working on is damaged. So we don't have to analyze the reason of the missing data. We just have to make sure that our data set is in good condition. When you create a data set from scratch, or when you convert a data set from one source to another, you might come across all kinds of inaccurate values. So the important thing is to know the data you are working with. So in order to understand if inaccurate value is a noise, for example, you have to plot the data and see if there is some kind of a strange behavior or some strange placement in the plot. If the data set is too big for having a clear picture of the quality of the data, you just take a sample. Sometimes it is required to in a real world condition to ask a domain expert, why is that? But we have many visualization tools to detect some irregularities in the data, and maybe also to get rid of them. When we do machine learning practice, we normally follow a number of steps. First of all, we must make sure that we understand the domain. So if we are linguist and we want to do word sense disambiguation, we must know word disambiguation very well. If we want to do parsing, we must know parsing very well. So then there is a pre-processing step where we get to know our data. We have to either create a data set from scratch and check that everything is okay, or to collect a data set from different sources and then analyze all the instances. We have visualizing tools to do that, so we can spot noise, missing values. We can also spot anomalies of all kinds, and this is very important because sometimes we have to get rid of noise, for example, because as we saw, noise can cause overfitting. Once we are confident that our data set is okay, we have to decide on the learning scheme. Usually we don't know in advance what is the best learning algorithm for our data. So we try several of them and we compare the performance. In order to compare the performance, we must interpret the results for real, not just comparing accuracies, but there are several other measures that we are going to introduce later, and they are very important to see how a learning scheme, a learning methods performs in combination with our data. That's all for lecture 2.